Hello there, math fans. How do you find the angle between two things, or the angle of intersection? This is a nice application of dot products. So I'm going to go through several examples of lines in 2D, curves in 2D, and then I'll talk about planes in 3D, curves in 3D, lines in 3D. This is something I always say to students, but often we don't see this till throughout the course, so I thought I would make a video that's just about all the applications of this thing, which I call this 10-star fact. The dot product gives indirect information about the angle between two things. And so in general, if you can find two vectors describing something you're interested in, and you can put those two vectors tail to tail, then you can find this angle. And the fastest, most general way to do that typically is to use the dot product. We do that by rearranging this. We say cosine of whatever the angle we want is this. And then we hit the inverse cosine button. We make sure we're in the correct calculator mode. So this is the general method for finding the angle between anything. So this opens up a whole bunch of questions on the so-called angle of intersection between two things, and so I thought I would show you some visuals. Now, generally when we're talking about the angle of intersection, we have two intersecting curves or objects, whatever they might be, that run into each other, I don't know, hit here in some way. And what we mean by angle of intersection is we mean the angle between their tangents. And I'm going to show some visuals of that in just a second. So often these questions confuse students because they have to understand what a tangent is, and then they have to use the formula. But that's really it. So let's go through and see that through a series of examples. And each one of this kind of shows the generality of this. What I find sometimes is that students they find some special way to do certain cases. What's nice is this applies to all these cases. Okay, so here's two lines. That's that angle of intersection. Now there's one ambiguity you might ask, which is what about this other angle? There is an obtuse angle and an acute angle, and in my vision, they're both perfectly fine. But if you want the acute angle, you need the appropriate vectors. So anyways, in this case, if I had two lines, let's say one of them has slope 2 and the other has slope 1/4. I just need to find two vectors. So I would need to find a vector that has slope 2, so some vector that has slope 2, and I would need some vector that has slope 1/4. Now what does it mean to have slope 1/4? It means you go over 1 when you go up 4. So I can give a vector that does that. There's lots of them, but one such vector would be 4, 1. This other one, I need a vector that has slope. Actually, that's slope 1, the picture I've shown. So let's draw one that has slope 2 and actually do what I said, slope 2. So when I go over 1, I go up 2. There's slope 2. So the hardest part is just getting used to thinking in terms of vectors. Once you have this, you're done. So you would do inverse cosine of 4 plus 2. And then you do the magnitudes of those vectors. Square root of 1 plus 4. Square root of 16 plus 1. And that's it. You have your handy calculator. You put it in the right mode. 6 divided by the square root of 5, also divided by the square root of 17. You hit the inverse cosine button. I'm in degrees right now, so I'm getting 49 degrees. So that's 49 degrees. It's pretty slick how fast that is. Now, if you did a search online, you probably would find something that would give you a formula that says if someone gives you slope 2 and someone gives you slope 1/4, there's certainly a formula involving probably arctangents to get the angle between them. But what I'm telling you is a general approach to any sort of angle question. All right, let's play another one. Let's talk about the angle of intersection of two curves. This is the homework question that a student was asking me about. These two curves are a cubic and a parabola. They actually intersect twice. So let's talk about that for a moment. So I have these two curves. We're going to restart. The curves in this case are 7x squared and 7x cubed. They actually intersect twice. I won't do that here, but they intersect at 0 and at 1. So there's two intersection points. The angle of intersection means the angle between their slopes. Now I'm going to rescale this slightly to make it easier for us to see. This is going to make the angle look distorted, but it'll be easier for us to look at. So it's not the angle between their locations, it's the angle between their slopes. Now the slope of this one and the slope of this one is different. At 0, for instance, the slope of both of them is 0. So actually I don't need to do any vector stuff. The angle between them is 0 degrees. You can see that. That's that horizontal tangent. The other one's more interesting. This one would have slope 14, and this one would have slope 21. And the moment you have that, you're done, because this is just like the previous question, except instead of slope 2 and a fourth, it's 14 and 21. Now visually what that looks like, I'll zoom in, is that angle. It's going to be a really small angle, but here's the line, tangent line with slope 14. Here's the tangent line with slope 21. If I get rid of the original ones, it's just like the question we just did. So I want the angle between slope 14 and slope 21. And we know how to do that. We can give a vector with slope 14 over 1 up 14, over 1 up 21, and then you're just multiplying 1 plus whatever 14 times 21 is, and then you need the length of this vector. So 1 squared plus 14 squared, the length of this vector, and you're off to the races. That'll be the other angle. So that's sort of interesting. Let's jump to 3D. That's when we really need this. 2D, you could find a formula probably somewhere. AI would help you. Here's two lines in 3D. Now in our course we'll eventually talk about those, and I've got them moving around. You could ask what the angle between them. Now it gets a little harder here because it's not, you can't talk in terms of slope. So a slope formula is not going to work. You have three things that are changing. It's hard to even see that angle. I tried to draw it. I'm not as good in this system, but I had to draw a circle of intersection of a few things, and that's that thing. So I'd like that, not that whole circle, but I just want the angle between them. How are we going to do that? The technique we just did still works. We're just going to need a vector that points each way, and we'll have those. Then we'll find the angle of intersection. We'll see another one. What about two planes? Here's two planes. When we go to describe planes, we're going to find this vector that's perpendicular to the plane. And I have two examples. We call it a normal vector. So the normal vector for the green plane is orange. Normal vector for the blue plane is red. The angle between the planes is, if you pull it to the side, it's those two angles. Now, just like before, there's an acute angle and an obtuse angle. And it turns out, if you look carefully at the angle between the planes and compare it to the angle between the normal vectors, they're the same. They're flipped in a sense because the acute angles are sort of opposite, bottom and above, compared to on the sides. But we see the angle of intersection between two planes is the same as the angle of intersection of two perpendicular vectors. So once I have those two vectors, I can do the same thing we just did, and I get the angle between two planes. Let's go to two curves in 3D. There's two curves in 3D. This is more exciting. We'll do this in chapter 13. They intersect. There you go. One of them's kind of a 3D parabola. One of them's a 3D cubic. And I have this. I want the angle at which they intersect. So first we find when they intersect, and then we're going to find tangent vectors. How are we going to do that? Well, we'll talk about that in that section. But we'll find a vector that points as a tangent vector for the green. And that's where we'll do this calculus. That's the calculus piece of curves. And we'll find this vector, this red, which is tangent for the other one. I want the angle between those two vectors. Do we have a way of doing that? Absolutely. I'm going to make this a little smaller so I can zoom in. Make this bigger. Absolutely, we can get that. So I just need those two vectors and I'll be done. So the interesting thing about these questions, an angle of intersection question, unfortunately does have a few steps. You have to figure out where the intersection is. You have to figure out two vectors, and then you have to use this. So it's kind of step 1, 2, 3. That does require that you understand the idea of slopes and tangents and how to work with vectors. All right, but I hope that gives you sort of the breadth of all the things this can answer. Any question about the angle in which things, and there's other ones I can think of, like if you have a ball that hits the ground in 3D, you could say, at what angle did it hit the ground? At what angle is it going to bounce up? All of this would be useful in answering such questions. All right, hope that's interesting.